Baseball is a fun game to play and watch, but there's a lot of physics in it, so in this video we'll be talking about the physics of baseball. There are three main components that both pitching and hitting enhance, and that is gravity, drag force, and the Magnus effect. David Ortiz, Corey Seager, Barry Bonds, they all happen to be home run hitters in the MLB, but how much science lies behind those home run hits? Let's see. One of the biggest contributors to a good hit is bat angle, with the normal angle of a bat swing being 30 degrees. A 10-degree enhancement of that could result in a 15 to 20 foot displacement additional, which leads to the question, how important is bat speed? Before answering that question, there's an additional factor when hitting a ball, and that is topspin and backspin due to the rotation of the ball. A backspin usually results in a further displacement, which I'll talk about later in the Magnus effect. While it is often confused, there is a difference between exit velocity and bat speed. Bat speed is the speed of the bat moving, while exit velocity is the speed of the ball after it hits the bat. Depending on the type of bat you're using, there can be an enhanced exit speed, therefore you could often see that pros use wood bats due to having a lower exit speed. Mind-blowing, huh? Now when a ball is hit, there's a reason it goes 400 feet instead of 900, and that is because there are three main components that slow it down. That is drag force, gravity, and the Magnus effect. The Magnus effect is the force exerted on a rapidly spinning cylinder moving through air or another fluid in a direction at an angle of the axis of spin. This is responsible for the swerving of balls, resulting in it going further. Now to transition into the second part of this video, I'll be talking about throwing, but mainly the pitching of baseball. The pitching of baseball is the manipulation of the speed and the spin of a ball to change the velocity and elude the batter. Here is my attempt at drawing a pitcher, but as you could tell, it did not work out, so please enjoy this moment. And do not laugh. There are three main components in when a pitcher throws the ball, and that is grip, pressure, and release, all for one cause, and that is to strike out the batter. The physics of baseball is surprisingly in the upper hand for pitchers, as there are two main components that help them out. That is gravity and the Magnus effect. So how does this Magnus effect help out pitchers? The Magnus effect is actually called the BFF of pitchers because as those nasty curveballs break, they wouldn't have that special movement that they have without it. There's also the knuckleball, which although it does not have the main components of the Magnus effect, it still is enhanced. Throughout the history of baseball, pitchers have created a dance-like motion to transmit energy to the ball by generating momentum from their body to create a faster pitch. And although it does look very weird, this is a very useful skill, as up to 3 horsepowers can be created by this motion. And like I said, this is the transmission of energy from your body to the ball. Now when any object is thrown, there is a large layer of air called the boundary layer in front of it, and at high speeds it causes the ball to be turbulent. That is why in multiple sports you'll see that balls have a certain texture to break up that boundary layer. And in the case of baseball, a baseball has 108 seams because smooth is bad, and therefore it breaks the boundary layer. Another reason why pitches could have a different movement is because of the 3 axes X, Y, and Z. With the combination of Y and Z, it could have different movements, resulting in the confusion of the batter and striking him out. So in conclusion, one of the main things that baseball players need is the Magnus Force. So may the Magnus Force be with you. Thank you.